Alright, so the next type of limit that we are going to find, or the next set of limits that we're going to find, are very, very different than the ones we've been doing. We're going to find the limit by what's called a change of variable. Alright, so I have my limit as x approaches 0. In the numerator, though, we have x plus 8 to the power of 1/3 minus 2 divided by x. Now again, a problem here is that x is, if we make x 0, that function is undefined. And I would want to factor out, as we have before, to try to factor out that x. But the problem is here I have this x plus 8 to the 1/3. So it's very difficult, well, it's almost impossible, somewhat, without using a change of variable, to factor it out. So what I'm going to do is, I'm going to make a substitution here, where I'm going to let u, I use the letter u here, equal x plus 8 to the 1/3. So making a substitution there. Now, what I want to do is simplify this in that when I put a u in here, I also need to know what x is, because I'm getting rid of all the x's and just putting in u's. Alright, so to get rid of 1/3, what I need to do is cube both sides. So I could say that u cubed is equal to x plus 8. Which also then, I can move that 8 to the other side, so again it would become negatives, changes side, is equal to x. And so now I have an expression for x in terms of u. I also have this x plus 8 to the 1/3 in terms of u. And so now I've got my limit. Alright, and instead of x plus 8 to the 1/3, I'm going to put a u minus 2, that 2 doesn't change. And then the denominator, I have an x. Well, I'm saying that x now, because of my substitution, is u cubed minus 8. Now, this is as x approaches 0. Well, I'm now dealing with u's to find the value of my limit. And so what I do is I go back up to here and I look at, well, what would u equal if I put a 0 in for x? So as x approaches 0, u will approach, well, let's see, I'm going to make a substitution in here, 0 plus 8 to the 1/3. Which is just 8 to the 1/3. And hopefully you can remember that really that means we're finding the third root of 8, which means what number times itself 3 times will give you 8? Well, the answer is 2. And so our limit now, instead of being x approaching 0 because we're dealing with u's, well, it's as u approaches 2. So there we've just switched our variable. But we still have the problem in that our denominator is equal to 0. So it's undefined, can't figure it out. But now I'm going to use another little math trick. We've had difference of squares. Well, there's also a formula, difference of cubes. Alright, so in this case, I do have a difference of cubes in my denominator. And so because u, well, really it is u cubed minus, and as I said down here, if I multiply 2 by itself 3 times, I get 8. A would actually be 2 cubed. And so I'm going to rewrite my denominator there as, say, u minus my a value, which I said is 2. I have a u squared plus 2 times u plus a squared, which again, my a this time is 2, so 2 squared is 4. Alright, so by using this difference of cubes factoring, I'm now going to change my denominator here, and so I have the limit. As u approaches 2, I've got a u minus 2 in the numerator. But now my denominator is going to be, because I did some factoring here, because again 2 cubed is 8, right? That's 2 cubed. And so my denominator now is u minus 2, which is a good thing, times u squared plus 2u plus 4. Well, now just what I wanted here is I've got my u minus 2's divide each other out, so there's just a 1 here. And so now I have the limit as u approaches 2. It's 1 over u squared plus 2u plus 4. Well, all our denominators are positive, so there's no way it's going to equal to 0, so I can substitute in my values. So I have a 1 in my numerator. 2 squared is 4. 2 times 2 is also 4. And then I have a plus of 4. And so our limit is equal to 1 over 12. Alright, so let's try another one of those again. Very difficult, lot different than what we've been doing. And again, we're throwing in this part here where we're now dealing with difference of squares factoring. We've dealt with we've factored quadratics using difference of squares and normal factoring, but that one's a difference of cubes. Alright, now again, we're going to find the following limits using a change of variable. I've got my difference of squares here, just in case I need it. You never know. So in example 5 here, we're looking at the limit as x approaches 27, which again is a problem here because our denominator is going to be undefined. And our numerator is, again, x to the 1/3 minus 3. So we cannot factor anything out if we just leave it as x's. So again, I'm going to make a substitution with our power here that's a rational number, or a fraction if you will. So I'm going to let u equal x to the 1/3. Alright, but again, if I cube both sides, I get u cubed. And then if I cube x to the 1/3, you just get an x. Alright, so let's see, I've got the limit as x approaches, whoa, we're not going to use x's anymore, get rid of that. We will get to that. So I've got that substitute. Oh, I also need to know what x equals. X is equal to u cubed. Alright, so we don't need to do that anymore. But I do need to figure out what because we're switching to u's, how my approaching is going to be. So as x approaches 27, what would u be? What would a u approach? Well, I put a 27 in here because we know u is equal to x to the 1/3. And so I would have 27 to the 1/3. Which again means we are finding the number multiplied by itself 3 times will give you 27. And that number in fact is 3. Because 3 times 3 is 9, times 3 is 27. Alright, so now I know that my limit now, as I've switched it all to u's, is the limit as u approaches 3. Because that's what happens as x approaches 27. In my numerator here, x to the 1/3 is u, and I have that minus 3, divided by here, let's see, x, which is u cubed, and then minus my 27. Well, guess what? Again, I've now switched everything, but I'm going to have to use a difference of cubes here because I do have it. And this time my a value is going to be 3, because again, 3 cubed gives me 27. Alright, so I'm going to end up with a u minus 3. U squared doesn't change. My a value I've said is 3, so it's going to be a 3u plus a 3 squared, which is 9. Alright, so now my limit as u approaches 3, I have u minus 3 in my numerator. My denominator now is going to be u minus 3 times u squared plus 3u plus 9. Alright, and just as before, guess what? We have a factor in the numerator and a factor in the denominator that will divide each other out. Which is great, because now we've got the limit as u approaches 3, 1 over, we got our u squared plus 3u plus 9. And again, they're all positive, so that means for sure I'm not going to have a 0 in my denominator. And so let's see here, I'm going to plug my 3 in, so I get 1 over 3 squared is 9, 3 times 3 is 9, and then I have a 9. And so our limit is going to equal 1 over 27. All right, now we have something a little bit different here in example number 6, where I am not going to use my difference as cubes. All right, we'll get to that. Now we have find the limit as x approaches 9, and we have the square root minus 3 divided by x minus 9. So again, our denominator is 0. That's a problem. But here's something we are going to use a ton in this course, is the fact that the square root of x can actually be written as x to the 1/2. All right, just like over here when we had x to the 1/3, that is really the third root of x. All right, and so I'm going to now, well, instead of writing the square root of x, let's see if I can get rid of that stuff. There we go. I am going to write it to the 1/2. All right, now again, I'm having issues being able to factor out something in the numerator and something in the denominator. So I'm going to again have a change of variable. And so the problem here is this square root of x, or the second root of x, just like the third root of x was a problem over here. And so I'm going to let u again equal x to the 1/2. And so if I square both sides this time, that'll get rid of my 1/2. I get u squared is equal to x. All right, and so then I have a substitution for x. I've got a substitution for x to the 1/2. That's why we're doing that. But now I have to figure out my approaching. So as x approaches 9, u approaches, let's see here, u is equal to x to the 1/2, or the square root of x. So I have this square root of 9, which would equal, of course, 3. All right, so now my limit, I can rewrite it with my u's in there, my change of variable. All right, so I have my limit as u approaches 3. My denominator, x to the 1/2, is u minus a 3. X minus 9, well, what is x? U squared minus 9. All right, so now that I have my change of variable, I have a chance of being able to factor things out. And in fact, I have a difference of squares this time in my numerator. So I have the limit as u approaches 3. X minus 3 in our numerator, that doesn't change. But again, u squared minus 9 I can write as a difference of squares, where we have u minus 3 times u plus 3. Which is much easier than our difference of cubes. But in the same fashion, those u minus 3's divide each other out, so we just got a 1 there now. And so now our limit is equal to u approaching 3. We have a 1 in our numerator, and now all we have is a u plus 3 in our denominator. And because that denominator is not going to be 0 when we plug a 3 in here, I can just plug a 3 in there, and so I'd have 1 over 3 plus 3, which of course would be 1 over 6. All right, so again, that's a new type of limit for us to go after, or to solve, but it's when we have a x value or an x variable with an exponent that is a fraction, which means you're taking the root, the square root, the third root, the fourth, well, we won't do the fourth root. We'll get up to the third root for this class. And that's how we do it. We got to change a variable. But again, you also have to figure out, as x approaches whatever number, what does u approach?